All right, today we're diving into a piece of tech that is, and I'm not exaggerating, rewiring the internet from the inside out. It's called P4, and it's basically giving our networks a brand new programmable brain. So, I want you to start with this question. Just think about it for a second. What if the very wires and switches moving all our data could do more than just follow a fixed set of orders? What if they could actually adapt, optimize, and even defend themselves all in real time? That's the huge shift we're exploring today. You see, for decades, our networks have been stuck in this box. They're built on fixed, rigid rules. They're reactive, meaning they can only respond to a problem after it's already happened. P4 is about flipping that script entirely, moving us to a world where networks are programmable, flexible, and, this is the key, proactive. They can stop issues before they even start. So, to really appreciate why P4 is such a game changer, we have to first understand the problem it's solving. And that problem is baked into the very hardware that our digital world is built on. The main culprit here is something called fixed function hardware. It sounds technical, but the idea is simple. It just means that the rules for how to handle every single bit of data are permanently burned into the silicon chip when it's made. It's locked in. You can't change it, ever. The best way to think about it is like this. Imagine a highway system where all the traffic rules, the speed limits, the lane markings, the exit signs are literally baked into the asphalt itself. You could never add a carpool lane for rush hour. You couldn't lower the speed limit in a storm. You're just stuck with the original design. That's pretty much how our networks have been operating for years. But what if you could repaint the lines on that highway instantly? Well, that's exactly where P4 comes into the picture. It is the key that unlocks the network's data plane. That's the part that's actually doing the work of forwarding traffic, and it finally gives us direct control. Okay, so P4 stands for, get ready, it's a mouthful, Programming Protocol Independent Packet Processors. But don't worry about the name. All you need to know is that it's a language designed for one specific, powerful purpose, telling network hardware exactly how to handle data packets. We're not talking about managing the network from some faraway computer. We're talking about rewriting the rules right inside the hardware itself. So, let's go back to our highway. With P4, it's like we've given the traffic control team a can of magic paint that lets them change the rules of the road on the fly. You need a new express lane just for streaming video traffic? Done. You need to instantly reroute everybody around a sudden traffic jam? You can actually program the road to do it automatically. So, how does this actually work? Well, the core idea is beautifully simple. First, you use P4 to define what a specific type of data looks like, what you're looking for. Then, you program the hardware to match any data that fits that exact description as it flies by. And finally, you tell it what action to execute. And the most incredible part? All of this happens at what's called line rate, which just means it's happening as fast as data can possibly move through the wire. There's no slowdown. Now, this simple three-step process, it leads to a really profound change. We're not just talking about a faster or slightly better network here. This is a whole new philosophy for how networks should even operate in the first place. There's a quote from the source material that just nails it perfectly. For so long, the brains of the network were in some central control room, totally separate from the actual flow of data. P4 pushes that intelligence right down into the switches and routers themselves, literally into the wiring. And what that means in practice is that we're finally moving from that reactive model to a proactive one. Instead of waiting for a problem to happen and get reported back to some central brain, the network hardware itself is making intelligent decisions in the moment, as the data is flying by at the speed of light. And this isn't just theory. It gives networks some incredible real-world superpowers. Things like getting a perfect, real-time snapshot of network health, or performing incredibly sophisticated load balancing to prevent traffic jams, or, and this is a big one, stopping those massive denial of service attacks, the ones that try to overwhelm a system with junk traffic, the very instant they begin. Of course, this kind of revolutionary power doesn't just come for free. It's a huge leap forward, but it also brings a new set of challenges and a new learning curve. You know the old saying, right? With great power comes great complexity. And it's true here. When you have the ability to program the very core of the network, you also have the responsibility to really, truly understand how that core works. That complexity is the trade-off for this amazing flexibility. So what are these challenges? Well, for one, developers have to work within the physical limits of the hardware. You can't just wish for more memory. Also, trying to debug a program that's running at billions of packets per second, Yeah, that's a whole different ballgame. It really requires engineers to have this deep, fundamental understanding of how data flows through the hardware pipelines. Okay, so let's zoom out for a second and land on the big takeaway from all this. What's the core idea that P4 really represents? This final quote really says it all. P4 is so much more than just a programming language. It's a fundamental shift in how we think about our network infrastructure. We're moving from being just passive operators of a fixed system to being active creators. This is really the mantra of P4. You get the flexibility and the intelligence of software to define your logic, your rules, but, and this is the magic, that logic is executed directly in specialized hardware, which gives you the absolute blistering performance of wire speed. It is truly the best of both worlds. And so that leaves us with this final, really exciting question. For the first time ever, the network itself is no longer a set of rigid, unchangeable rules. It's a blank canvas. It's programmable. The fixed rules are gone. So the only question left for us to answer is, what amazing, efficient, and secure things are we going to build on it?